Welcome to this tutorial today. Kindly subscribe to this tutorial. So that every time we get to upload an tutorial, you'll be able to get the tutorials, the notification. So welcome. Today we want to look at order and degree of online differential equations. Order and degree of online differential equations. We want to know what is order and what is degree, and given OD, how do you identify the order and the degree of that OD? So by definition, order is order of a derivative is k if the dependent value has been differentiated k times. If the dependent values has been differentiated k times. Order of a differential equations is the order of the highest derivative appearing in the differential equation. Is the order of highest derivative appearing in the differential equation. So, what about degree? And degree is the highest power. It's the highest power to which the highest derivative is raised to when all the powers are positive integers. Mark that, are positive integers. Highest power, that's a degree, to which the highest derivative is raised to when all the powers are positive integers. Let's look at an example here. We have this example. This is our hair. So this is our hair. This is our B. This is our C. So if you look at our A, we want to identify first the order. We identify the degree. So if you look at the first equation A, you'll find as per the definition, the order is the highest derivative appearing in the differential equation. So let's note the highest derivative. So the highest derivative in this, we have d cubed. This is d only. This is d cubed here. This is only d power 1. So you'll see that the highest derivative here is third derivative. So that means that this is of order 3. This is of order 3. Order 3. A is order 3. Is order 3. Let's look at B. The highest power, highest derivative is, this is 1, this is also 1. So it misses the 1. What about the other one here? We have 4, we have 5, we have 1. So the highest is 5. That is order. So C is order 5, B is order 1, and A is order 3. I think everyone, we are okay with it. We are okay, we can see that. Then degree, what about degree of A, B, C? Degree is highest power to which highest derivative. So this is the derivative whose we have used to get the order. So let's look. The first one, we are saying the order is 3. Is 2 power what? It's automatically 2 power 1. So that's degree 1. B is power 1. But the highest derivative, the highest power in this is 8. Because we have power 8 and we have power 4. So 8 is the highest power. Okay, for C, you'll find that We have said 5 is the order, so that means its highest power is 4. That means it's the degree. So if we check to the answer solution, we have said A is OD, of course, of order 3, degree 1. PD is B is a PD, of course. We know the meaning of PD from our previous tutorial. So if you did not see the first tutorial about difference between OD and PD, that's partial derivative and ordinary derivation, you can check on our previous video and see how we talked about that. So this is a PD of order 1 and also degree 8. Then C is also a PD of order 5 and degree 4 So kindly, if you have any question, any comment in the comment box down there, kindly put your comment down. If it's a question that you want us to look at, just put it down there. I will look at it and share with you. And remember to subscribe. Now let's look at another example. We have this example here, whereby we have cube root of y plus 2 square root of y. I think the first one is tan derivative, and the second one is tan derivative, second derivative equal to x. Now we have this kind of equation here, and our interest here is basically to get the order and to see whether we can get the degree of these equations. So in this equation, which is basically a ODE as fraction powers, because at that, if you get the square root of cube root is something to power, if like a to power that. So you can see that power is a fraction. Square root is power to a half, which is also a fraction. But remember our interest, what we said, we emphasized on this, we saying that it should be a positive. To get the degree of any given OD, then it should be a positive integer. So these are not positive integers, of course. So for us to note degree and order, we need to make sure that powers are positive integers. So what do you do about this? We have now to convert our equation to have integers, powers. So in this case, what I've done here is basically getting cube power 3 every signed. So I powered by 3 here, powered by 3 here, by 3 there. So if you do that, you'll find that let's extend this one. So if you expand that one, you'll find you are getting this. So x minus 2 root second derivative of y, you'll find that you get this if you expand. Collecting like terms together and putting them on either side. So without root second derivative, go to the left side. So you have that, and you can see the other one here is left here. So next, what do I need? I want to remove the square root here, this square root here. So what do? I square both sides. So when I square both sides, I'll have this on the left hand side, and the right side I'll be left with this. Expanding, you'll find that after expanding, you are getting this kind of equation. So when you expand that, you see that I don't have now, I have the integers as my powers here. So I can basically be able to note the order. So which is the highest derivative here? So I see the highest derivative here, which is the order is basically 3. You have 3 here, and the highest power of that 3 I see is basically 2. Is 2. So that means this is a only of order 3, degree 2. Degree 2. Again, if you have a question on that, how we expanded that, you can leave a comment and I'll be able to look at it. So, a remark. We can only classify a differential equation of having a degree if, and only if, this is very key, can be written as polynomial equation of different variable and its derivatives. So we can only classify and differential equations of having a degree if and only if can be written as a polynomial equation of what? Of dependent variable and its derivative. So if we can write that equation in that form, then remember we can get the degree of that given dE. So that marks the today lesson. Kindly subscribe so that every time we put on any tutorial, you'll be the first to get it. So leave comments down there. Any question that you want us to look at, I will be grateful. So bye for today.